Hello, this short video session is going to be really impressive because I will be designing a real-time messaging app which will enable real-time communication between not just millions and billions of humans on planet Earth, but also trillions of aliens from so many different planets in this universe. I'm not sure if that is a good news or a scary news, but Elon Musk and Jeff Bezos are definitely going to be impressed because they need it. And I'm not kidding, I'm serious. I will be doing it right now, right away in this short video session. So please be patient and watch the whole session. Before that, I would like to answer a very obvious question: how my system design videos are going to be different from so many other system design sessions which are available on the internet. Well, following are those reasons. First, uniqueness. Over a period of time, I have developed a unique way of looking at the problem solving, and I would love to share this with the whole world, which will help listener build more perspectives and learn better techniques. Second, my content is really simple, concise, minimalist, direct to the point, start with the heart of the problem, which will help the listener to stay focused only on the most relevant and important pieces of the system design. Third, there is a progressive flow of thought and a precise sequencing between them, which will help the listener learn it gradually, and we will reach the complexity in small stages. Now, I would like to describe the format of this session. We will start with the core functionality, and once that is done, we will add only one feature. Why we will add only one feature and not many? Because the whole idea of this session is just to explain how feature addition can happen on top of the core functionality without breaking the core design and principles. Now I would like to explain the format of the session one more time, keeping in mind our specific use case of designing the real-time messaging app. The core functionality here would mean that a user should be able to send the message in real time to another user or a group of users. Once that much is done, we will add one feature, and we will add the feature of restriction. We will restrict the user to not send messages to more than 5 people. So once he will try to send the message to the sixth person, he will be restricted and he would need to buy the premium package from the developers. Otherwise, he will not be able to send the message to the sixth person. That's what we will add as a feature on top of this core functionality. Once this much is done, we will move to the scalability. And scalability here would mean that our platform should be able to gather requests from millions and billions of people around the world and the universe. And our platform should not be slow. There should not be a degradation in the latency, in the slowness. It should still be responsive, fast, and should not show any fluctuation or any sort of bad behavior to the end user. Now let's start with the implementation, and for the implementation I will draw some diagrams, and we will start with a very minimalistic view. There will be a user who wants to send a message to another user or a group of users, which means we have three entities: from user to user and the message. But this whole thing will be covered under another entity, and we will call it conversation. So this conversation will be the most parent entity, and this conversation entity will have from user to user and a number of messages sorted by their timestamp. This whole thing will be part of this bigger entity called conversation entity. For now, we have drawn all the entities which will participate in the system design. Now we will move to the actual flow of request and response. For that purpose, I have drawn another diagram, a very simple minimalistic diagram. We will have a client application and a server application. The client application is the one from where the user is sending the messages, and the server application is that actual architecture, the actual platform which will be ingesting these messages. There will be a request and there will be a response back. Now let's have a detailed view at how this request and response would actually look like. In order to understand this request and response, we need to understand that there can be two kind of requests. The first kind of request would be called the initial request, which will be sent at the most beginning when there is no conversation. So conversation means there has not been any initial conversation, which means we do not have any conversation ID yet, and user wants to initiate a conversation to the user. And the another kind of request would be continuation of existing conversation, which means user had already initiated one conversation with another user. Now he wants to send a message in that conversation, which means we have the conversation ID already in the system. Now we can have a look at those requests and responses from this perspective of initial conversation and continuation of existing conversation. The sample request can look like this: the user ID from which it is being sent, the user ID to whom it is being sent, and the actual message. That's it, very simple. This is going to be the initiation of the conversation from this user ID to this user ID. And the response can look like a conversation ID. Now the another initial request, we will call it request 2, will be an initialization of group activity. Now a user is interested in creating a group of all these user IDs together. So in that case, our request message, our request JSON would look like this: the user ID from where it is coming and the user ID to whom he is interested in sending his message, which means he's interested in creating a group with all these user IDs. And the response would again be a conversation ID. So till now, our client application have received the conversation ID, and rest of the conversations, which will be the continuation of those conversations, will look like this: from user ID to user ID, which conversation ID, and what is that message. And the response can simply be a status. It can be delivered, in progress, or declined, which will be a specific status, or it can simply be an HTTP standard status also. Well, so far we have successfully created our core functionality. Now we will move to the next section, which is adding one feature on top of this core functionality. For this purpose, we will make some changes to our architecture without breaking the core principles. And we will move to that diagram where we have the request response model and the client was communicating to the server. We have drawn this one new service and we have called it status check service. What is going to happen? Our server at the request, the initialization request, a user is interested in communicating with the sixth person. He had 5 conversations so far. Now he is interested in creating sixth conversation. At that point of time, the request will come to the server and server will check it with the status check service. What this status check service will do, it will talk to a new entity and we have called it user conversation mapping. This entity will be the mapping between user IDs and all the conversation IDs, just to keep track of how many conversations a user had so far. And this new service will check that from this particular new entity and give back the response whether this new initialization is accepted or declined. Depending upon that, the server will redirect the same response back to the client, or will probably alter it or customize it as per his own configuration. The user will either be allowed to create that conversation or be declined. So far, we have successfully created our core functionality and we have added one feature on top of it. Now we will move to the scalability part. In order to understand the scalability, we need to draw a few more diagrams and we have drawn that already. Here are the minimalistic entities which will participate in making our application scalable. We will have an API gateway, then we will send those requests to the load balancers, and load balancers will initiate and terminate the server instances dynamically as per the load. But before that, we need to understand what kind of changes we had to make in our infrastructure to make our application scalable. Well, we need to do following changes. We first of all need to make our application stateless. It means none of the servers which will be entertaining any of the requests should have any session information with it. And second, we will containerize the application. Containerize means we will use a containerizer infrastructure which are available by many cloud vendors, or probably if the organization have created at their own in-house, we can use that. And this is how a standard script file looks like from a sample Dockerization, which is one of the containerization service, very popular one. This is how a sample script file look like. So what we will be doing, we will be containerizing the application, and we will be giving it to that containerizer infrastructure, which will speak with the load balancer and the auto scaling group to initiate and terminate server instances as per the load capability. Apart from these two changes, we might need to do one more change, and that one change will come between the request and response. So there will be an intermediate response ID, let's call it status response ID, which will not be the actual conversation ID which we had drawn in the most beginning. Instead of getting the conversation ID in our response, we will get the intermediate response ID, and we will check the status of that response ID. The client application will talk to our servers multiple times to check whether the request which they had sent has been fulfilled or not. This we may need to do because in order to scale the application, we might be adding a queues, which means all the millions and millions of requests will first go to the queue. Then there will be a pub sub model, there will be broker, and the subscribers will be listening to those queues. Hence, we might be creating a intermediate response ID, not the final response ID. The final response ID will be created once that intermediate response ID is getting fulfilled, which means the server have now picked up the request from the queue and have completed its job. So far, we have successfully scaled up our application. We have not just created the core functionality and added one feature on top of it, but we have successfully scaled it up. Now, millions and billions of users can use it. We can add few more attributes in our infrastructure. For example, we can add a CDN or global accelerator, which will make our API gateway near to those users which are in probably in some other country or present in some other area which is highly intense in terms of traffic. So CDN will fasten up the request response cycle here, and we may implement certain number of caches at different layers, not just at the front of API gateway, but also probably one cache can happen in the most beginning of the CDN, and one cache can happen after the load balancer also. This will also fasten up the request response. Congrats, we have successfully created an application which can be used by millions and billions of users concurrently. Now aliens can talk with us. Again, I'm not sure if that is a good news or bad news, but see you in another video. Take care. Bye.